Hi, and welcome to the video on measures of location. So, if we've got a set of data, then it can be summarised by talking about its centre. And we want a single number at the centre that describes it. And so this number we're going to call a measure of location. Now, in the past we would have just called that an average. And so our three different types of average are the three that you already know: mode, median and the mean. So recall, the mode, our first measure of location, is the value that occurs most often. So what I'd like to do is pause the video and have a go at finding the mode for these three sets of data. Right, you should have done that. So in part A, you should have found that the mode is 8, because that occurs most often. In part B, the mode is both 26 and 32, because they both appear twice and no other number does. And so in this case we would say that this set of data is bimodal. There are two modes. In the last example, there is no number that occurs more often than the others, and so for this one there is actually no mode. Right, let's move on to our next measure of location then, and that is the median. So the median is the middle value when all the data is put in order. So again, pause the video and have a go at finding the median for each of these sets of data. Right, so let's have a look at the answers. So in part A, if we put it in order, we should get 2, 3, 4, 5, 6, 8, and 8, and it should be pretty clear that the median is 5, because that's the middle value. In part B, if we put them in order, and one way of helping you put them in order is underlining them as you do them. So we've got 13 first, the next biggest value is 22, and the next one is 26, and there are two of those, and the next one is 27, then 29, and 30, and two 32s, and finally 48. So to find the middle value, we cross them off from either end until we're left with what's in the middle. Now in this case, we have two values left in the middle. And so to work out the median, we find the number halfway between them, which we can do by adding together the two numbers and dividing by 2. In this case, we get the median is 28. Right, so let's move on to our third and final measure of location, which is the mean. Now recall that when we're looking at the mean, we add up all the pieces of data and then divide it by how many there are. But this can be expressed using this formula. Now this is the Greek letter sigma, and it stands for the sum of. So what this is telling you to do is add up all the pieces of data, because x is standing for every piece of data. So this literally means add up all the pieces of data, and if n is the number of pieces of data, then we're being told to divide by n. Now instead of having to write the mean of this data is, we can use this symbol here. An x standing for our data, our set of data, with a bar on top. So that means the mean of our data. And by our data, what I'm thinking of is a sample. So if we take a sample of some data, we want to find the mean of it. We'd use x bar. Later on in S1, we're going to look at the mean of a population. And in that case, we'd use this Greek letter mu, which will stand for the mean then. But we'll come back to that when it's necessary. So, pause the video, have a go at finding the mean for this set of data, and in particular try and use the correct notation. Okay? Right, so if we have this data, we want to find the mean of it. But to say finding the mean of this data, then we can use x bar, that stands for the mean. And that is just the sum of all our pieces of data divided by how many there are. Well, if we add up all this data, we get 35. And there are 1, 2, 3, 4, 5, 6, 7 pieces of data. So we're dividing by 7. 35 divided by 7 is equal to 5. Now in this one, the questions can be slightly more complicated than that. So let's look at one final example. So, the mean of a sample of 25 observations is 6.4. The mean of a second sample of 30 observations is 7.2. Calculate the mean of all 55 observations. So for the last time, pause the video, have a go at answering that question. Right. First thing in trying to answer this question is, well, if these 25 observations have a mean of 6.4, we can work backwards to find out what all of these things would be added together. So what we would do is we would do 25 times 6.4, and that comes out as 160. So that means the total of all these 25 pieces of data would be 160. But we can do a similar thing with these 30 observations. So if we do 30 times the mean of them, 7.2, we find that we get 216. And so 216 is the total of these 30 pieces of data. So altogether, if we take all the data all together, what we're going to get for the total is these two things added together. And so the mean of all the pieces of data is 160 plus 216. But this time, we need to divide by the total number of observations, total piece of data. Well, that's 55, isn't it? But if we weren't told it, we know there are 30 from this set, 25 from this set. So again, either way it's 55. And when we work that out, we should get 6.84. So let's just recap what we've done. We took the mean for these pieces of data, we worked out the total by multiplying these together. We worked out the total for these 30 pieces of data by multiplying it by the mean. So we then added the two totals together, divided by how many pieces of data we have. So if we were going to write this as a formula, we'd say if we have this set A that has n1 elements, has a mean of x1 bar, and we have another set, set B, that has n2 elements and a mean of x2 bar, then what we'd do is we'd multiply these two things together to get the sum of all the elements of the set A, and we'd multiply n2 and x2 bar together to get the sum of all the elements in set B. Then we'd add together those two things. So we get n1 times x1 bar plus n2 times x2 bar, but then we divide by how many elements we have altogether. Well, that's just the number of elements in set A plus the number of elements in set B. And so we get this formula. Right, that's the end of this video. Make sure you've completed the sheet before the next lesson. Thank you.